Welcome to our presentation of our Rube Goldberg drawing. My name is Brady Newsom, and this presentation will help explain physics concepts using a Rube Goldberg machine, and the end goal is to find the love of Kameron's life on Tinder. The physics concepts that will be explained in this video include kinematics, momentum, conservation of energy, forces, and rotational motion. Like it says, we will be finding the love of Kameron's life. So, the first concept we'll be going over is called kinematics. The definition of kinematics being a branch of physics and mechanics that deals with motion of bodies or systems of particles with regard for the forces or masses involved. The outlined image depicts a photo of a potato cannon being fired. At the point where the spud exits the launcher, it's moving with a positive velocity at an upward angle. It will continue its upward ascent while slowing in velocity. When it reaches its highest point of its trajectory, the spud will have a velocity of 0 meters per second. The spud will then begin to head in a downward angle at a negative velocity.
All right, the next concept we will cover is momentum. The definition of momentum being a vector quantity with both magnitude and direction. The image shows a paddle moving with some momentum after it's been hit by the potato from the previous concept. The first paddle collides with the second and will continue to move in a positive direction with the same velocity or slightly slower velocity depending on the masses of the two paddles. Momentum is conserved in the collision and is an elastic collision, therefore the energy will be conserved. Additionally, there are not any external forces acting on the two paddles at any given point, so there are not any impulses or changes in the momentum. The paddles will then hit the marble that will be shooting down the track. And that brings us to our next concept, which is conservation of energy. The definition of conservation of energy is a principle of physics that states that the total energy of an isolated system remains constant over time. In a boxed-in area, we can see the marble going down the track. At the top of the track, the kinetic energy in the marble is 0. There will be a considerable amount of potential energy at this time. Then when the marble starts to move downward on the track, it will gain an increasing amount of kinetic energy while losing its potential energy. Eventually, the marble will only possess kinetic energy while it's moving along the track, and the total amount of energy will be constant throughout the entire motion of the marble going down the track. And there's also no work being done on the marble because there are no external forces acting on the marble, given that friction is negligible in this situation.
Hi, I'm Luke Hellmich. The next topic being discussed is forces. The definition of forces is a vector quantity that has a magnitude and direction. It is an influence or a dynamic influence that can change the motion of an object with mass. The marble will go into one of the two held up boxes shown in the marked area. The mass of the marble will cause the box to be weighed down and to move in a negative direction. The two forces that are acting on the box, as shown by our free body diagram, are gravity and tension, due to the rope attracted to it. Before the marble goes into the box, the two forces are at equilibrium with one another. However, after the box gains more mass via the marble, the two forces are no longer equal to one another. This causes the box to move downward.
Okay. Hi, I'm Olivia Schrock-Bobb. Let's just get on. All right. So our final concept we are going over today is rotational motion. Rotational motion is the motion of an object around a circular path in a fixed orbit. In our machine, we have a wheel rotating in a counterclockwise motion. The wheel stays in the same spot, so its angular velocity is constant. This makes the angular velocity 0 throughout the entire rotation of the wheel. The center axis of mass is where the center of the wheel is located.